Hey folks, welcome back. This is Joel, and I'm going to dive deep into VPNs again today. Today we'll be looking at one of the last topics in VPN, which is FlexVPN, right? And we'll be especially looking at the site-to-site configurations of FlexVPNs, right? So a bit of background, right? What you're seeing on the screen, what we are going to do today is, um, we're going to look at these three routers. We're going to use these three routers for configuring FlexVPN. R6 is anyway going to be my service provider, which we have pretty much done in almost all of our earlier sessions, right? And I'm going to establish a VPN between R1 and R2, right? Now, if you observe carefully, I have mentioned the IP address of this interface on R2 to be a dynamic IP, right? So a easier way to do this would have been by configuring SVTIs, right? SVTIs are basically static virtual tunneling interface, wherein we don't use crypto maps and we use tunnel mode, which is IPSEC, right? So that would have been an easier way to do it. But then because the IP address over here is continuously changing, I can't use that approach anymore because as the name says, it is static virtual tunneling interface, right? So if I'm using SVTIs, I will have to define my tunnel source and destination on my R1. I will also define my tunnel source and destination on my R2, right? And since the IP over here is continuously changing, I will not be able to define a tunnel destination on my R1, right? So that would fail. So how do we do this? So in order to solve this, we're going to look at FlexVPN, and it's going to be a combination of SVTI and DVTI, right? So DVTI is basically dynamic virtual tunneling interface. So since the IP address on my R1 in this example is going to be constant, which is this one, right? So I'm going to use a SVTI which would go from R2 to R1, right? Whereas since this IP address is continuously changing, we are going to use a dynamic VTI from R1 to R2, right? So that's going to be the whole background about it, right? So let's get started with the configurations, right? Let me spin up all my routers. Let's connect them now. Great, right? I would want R6 to start with because that's going to be my ISP, the center one. So let's put some IP address configuration on my R6, right? So the IP address configuration would be, let's do that. Let's go down to the configuration mode and yeah, there you go. So this is going to be my IP addresses on my R6. So I have a interface Ethernet 0/0 towards R1, 0/1 towards R2 over here, and 0/2, 3, and I'm gonna put them now because probably I'm gonna use the rest of the IP addresses and the interfaces maybe later in this video or the next video, right? So I'm gonna put them for now. So let's run this, right? So we have put the IP addresses on all my interfaces from R6. Great. So now what we are going to do is we are going to let's also finish putting in the IP address and routing on my R1 and R2, right? Let's do on R2 probably, right? So on R2 we gotta do that. So we will have the Ethernet interface on my R2, right? Ethernet 0/0, and the address is going to be 192.1 and 20.2, right? And the loopback address is going to be 10.2.2.2, right? I'm going to use that. I'm going to use 10.2.2 over here, and I also need to have a default route. I'm going to put a default route on my R2, which would basically point towards my ISP, which is 192.1.20.6, which we just now configured, right? So I'm going to put that. Let's also do the same very similar configuration on my R1, basically the IP and the IP address and the routing configuration, right? Let's finish that. So that's basically on R1. So we have the interface, right? We have the Ethernet 0/0, and there's an IP address on that 192.1.10.1. We have the loopback address on R1 as well, and then we have a default route, right? With that, I think I missed mentioning the default address here, so let me quickly do that so that it's easier to understand. It's going to be 10.1. Probably 0/24. So this network is going to be my loopback over here, and my loopback on R2 is going to be 2, right? It's going to be 2.2. Yeah, great. So we've got all configuration done, which means, I mean, I've got all my IP configuration done. So I can quickly check that. Let me clear the screen. Looks a little bad. Sorry. Here, let me clear the screen. There you go. So let's ping. Let me ping first the gateway, which is 192.1.20.6, right? Yeah, that works. Let me also ping my R1, which is 192.1.10.1, right? There you go, it works. So there is connectivity between these two routers now, right? So now we are going to dwell into the VPN configuration, basically the FlexVPN, right? So let's start with configuring my spoke, right? That's going to be easy. So my spoke is going to be R2, right? So I'm going to do that. Remember, we are doing a static VTI from R2 towards R1 because we have a static IP address in this case on R1, whereas the IP on my R2 is dynamic, right? So whatever comes from R1 to R2, that's going to be my a dynamic VTI, right? So let's start with the static VTI on my R2. Let's go down to R2, right? Let's do that. Let me clear the screen as well. Great. So R2, let's start with we are going to use Ikev2, which we did in the earlier classes, videos, I would say. So this is going to be my Ikev2 proposal, right? So I'm going to initiate a proposal, prop1. I'm going to define a encryption, integrity, and the group as well, right? We have done this in the earlier one, so you can refer there for more explanation, I would say. The next one is, the second step is always define a policy, right? We have defined the proposal. Next is we have to define a policy, which would in turn call the proposal. So we are defining the policy 1, and we are, attaching the proposal which we just now defined. That's done. The next is very important for the authentication point of view. We need to have the keyring. So let's define a keyring. We are calling the keyring as KR212. The peer router for R2 is R1, so I'm going to define R1. Address is 192.1.10.1, right? Pre-shared key Cisco 123, right? The peer address is 192.1.10.1. We are using a static address because the address on my R1 is constant, right? And I'm using a common key for both my local and remote authentication, which is Cisco 123. I think that's good. Now the next part is we have to define another profile. We have to define a profile called as Ikev2 profile, right? That's important. So we start with the profile. We give a name for the profile, and then we need to tell the peer address, which is 192.1.10.1, and observe carefully what I'm doing here because I'm going to do a small change here when I'm going to my R1, right? When I do the configuration on my hub, I'm going to do slight changes. So this is how I do it on my spoke, right? Where I explicitly define the address without any subnet. It's clearly, I'm like static. It's a kind of like a static configuration. I'm explicitly telling it is 10.1. Then I also need to mention my authentication, local and remote, and I'm telling them I'm using pre-shared keys in both the cases. The keyring local is KR12, right? The keyring which I earlier defined, I'm attaching the keyring to my profile over here, Ikev2 profile, right? Great. So we have done with phase 1. Now if you see the phase 2 configuration, which you have done since day 1, it's pretty much the same. I'm using IPSEC, and I have the ESP, triple DES, and ESP MD5 HMAC here, right? That's good. So we've defined Ikev2 profile. Now we need to go and define what you call as the IPSEC profile, right? Because in this, when you're using tunnels, we normally use crypto maps, remember? So IPSEC profile kind of helps you prevent using crypto maps, the legacy crypto maps. So I'm going to use IPSEC profile, define a profile here, attach my earlier Ikev2 profile to this, and I also need to attach my IPSEC, or basically the phase 2 configuration, right? Which is ABC. My phase 2 crypto command, was basically a transform set, which was ABC, and I'm attaching the transform set here. Great, we have done all of that. Now comes the interesting part, right? The tunnel, right? The tunnel which we are talking about. This is the place. So till now, whatever we have done will remain, the most of it will remain exactly same on my R1, right? When I go and do the configuration R1. But from now what I do is kind of different, and this is where you can see the changes between SVTI and DVTI. So you see here, because it's a SVTI, what I do is I explicitly define the tunnel. I put an IP address on the tunnel, 192.168.12.2, which is my private address on my tunnels. And I also define the source for the tunnel, which will always be Ethernet 0/0. The destination, I'm hard coding the destination here because we know explicitly that this is a static IP. It will always be configured on this router. It is not dynamic. And the IP4, IPSEC IP4 is the mode, and we also need to define the protection of IPSEC, which is IPROF, which I earlier defined as part of the IPSEC profile, right? So this is how we do the SVTI configuration. Great. And the last part, we need to just do the routing, right? So remember, we had done just the default route. We had done a default route on this router. So these two routers were able to reach to each other on these two interfaces, which is Ethernet 0/0. But what if the 10 network of this router wants to talk to the 10 network of this router, right? So we need to advertise these IPs. So I'm going to put in a very simple routing protocol so that the communication happens over the tunnel, right? So that should be the last piece. So we have the Ethernet, EIGRP 100. I also put in no auto summary. 192.168.12.0 is my private address space of my tunnel, and I have my network as well, which is 10.0.0, right? Pretty good. Yep, that's done that. So that is basically the configuration that goes on my R2, right, which is my spoke. Now comes the interesting part. We have to do the configuration on R1, right? So let's do that. Let me start with phase 1. Let me pull up all the configuration for phase 1 so that I can explain all of the phase 1 in one shot, right? So this is the phase 1. Ikev2 proposal. This is same as what we did on R2, right? We have to define a proposal, attach my encryption, integrity, and group to that, and then I define a policy which would attach my proposal to it, right? The next step is defining the keyring, right? The keyring, you can use the same name or something different because this is locally significant. And my peer router is going to change now to R2. It was R1 earlier. And my address. So this is something interesting. If you look here, earlier, when we did the configuration on R2, we explicitly defined this address to be 192.1.10.1, right? Because it was a static IP. R1 as a static IP, but because R2 doesn't have a static IP, I'm defining the whole subnet here, right? So the key or the authentication gets established with any of the IP address, right? And not just because it's continuously changing, it's a dynamic IP space. So I'm explicitly defining a subnet here. So this has to be noted because this is slightly different from what I did with my SVTI. So what I'm doing right now is DVTI, right? It's dynamic. So yeah, so the whole subnet has to be defined here. The pre-shade key has to be same as what you defined earlier on the other direction, right? And the next part is the Ikev2 profile. Even that is important, right? So we have two profiles. One is the Ikev2 profile and the other one is your IPSEC profile. So first one is the Ikev2 profile, and here also you need to observe that the identity or the remote address is not just one address. I have defined the subnet, and the reason behind this is because that particular router R2 has a dynamic IP, so it can take any of the IP in this space, right? Any of the 256 addresses. So I have defined a subnet here. So that's a difference with compared to the previous one. The rest all remains to be same, authentication, and then we have a keyring, and this is a very interesting thing. So I have defined something called as a virtual template 12, right? So how this works is virtual template. Okay, why did I do a virtual template on my R1, right? So like I said earlier, we are talking about doing a DVTI, right? And you see that we actually don't have the tunnel destination. So when I'm doing the configuration of the tunnel on my R1, I legit don't have my tunnel destination because this IP is continuously changing, so I can't hardcore anything here, right? So we do something called as virtual template. So we create a template which would have all the other features of the tunnel, right? Like for example, the tunnel mode, the tunnel source and tunnel protection and all of that, and the only missing parameter, which is my tunnel destination, will not be put inside the virtual template, right? So we create, you can assume virtual template to be very similar to a tunnel configuration, but without the tunnel destination mentioned in that, right? I think that's pretty right. So yeah, so that's basically virtual template. So what happens when my internet service provider here provides my R2 with the IP address, right? It could be different. It could be 192.1.20.1. Maybe after some time it could change to 20.3. So whenever my ISP provides my R2 with the new dynamic IP address, so R2 will initiate a tunnel towards R1, right? Why? Because it has a SVTI configured on it. So it will initiate the tunnel and will try to authenticate, right, with the password which is Cisco 123. Now when R1 sees this, it immediately knows that it has to use the template which is configured on it and create a tunnel towards R2, right? And yes, we don't have the destination IP on the tunnel, so R1 will use the IP address from the tunnel request which it just now received from R2, right? So if R2 has an IP address of 192.1.20.2, right? So R1 will basically use this as the destination IP address and create that tunnel towards R2, right? So that is the place where virtual template comes into picture. So we create the virtual template on R1, and that virtual template is basically very similar to the tunnel configuration except the tunnel destination. So I'll tell you the virtual template configuration as well. For now, just remember that I have attached my virtual template to my profile, right? So let's put this. So the next part is the phase 2 configuration, which is pretty much the same, right? That's good. Now comes the IPSEC profile. No change here as well, right? The IPSEC profile, we attach the IPSEC phase 2, and we also we attach the transform set, we attach the Ikev2 profile as well, right? Okay, I think there was a mistake. Something did not go. Okay, let me. Okay, so I think that was a comment, so that's fine, that works. So all my three commands have gone in. That's good. So now comes the interesting part about configuring my virtual template. So how do I do that? Right, I was talking about the virtual template, right? So this is your actual virtual template. I need to use the same number like earlier. So I need to use the same virtual template 12. The type is basically a tunnel, right? And IP unnumbered loopback 12. Why did I do this? So when you define a template, you are actually not allowed to type in any IP addresses under it, right? You can't manually configure anything under a virtual template. So what I do is I create kind of like a dummy loopback address. I have called that as loopback 12, and I attach my IP address for that loopback address, for that loopback, right? So I put in my physical IP for that loopback interface over here, and then I tell my virtual template to fetch the IP address from the loopback interface. So this is how I do it. Pretty simple. Then we have the tunnel source. Carefully observe that we don't have tunnel destination, and tunnel destination will basically be picked when R2 will initiate a connection towards R1, and R1 will realize that, hey, I have a virtual template configured in me, so let me use the IP address with which R2 communicated to me, and let me initiate that tunnel towards R2, right? So that's how you get the virtual interface, up and running, and that's how you're able to take care of the dynamic IPs here. And the rest is same. So we have the mode, and we also have the profile setup on this, right? So that's my virtual template, right? So the last part is the routing. Just like we did earlier, we're going to do the routing. Right? So let's do the routing as well. Great. So what do we do now? So we have done all the configuration, and let's see if let's look at the status, right? So let's look at some of the things. Let's look at the route probably. Okay, so I'm on R2. There seems to be an issue. Let me check. I don't see the R1 routes here. So okay, so my tunnel is up, which is good. Okay, the tunnel came up now, right? It takes a bit of time. So the tunnel came up now. If I look at my routes now, I think it should be good. Yeah, I think it's good. So I can see my R1 routes, in my R2 as well, right? Great. So let me ping now just to confirm everything is working. So I'm on my, let me probably clear the screen. Maybe that'll be better. Yeah. So let me ping my R1, which is 10.1.1.1, and source this from 10.2.2.2, right? There you go, it works, right? Let me also show you the IPSEC configuration, basically the VPN configuration, right? Let me pause this. That was a call, my mistake. Anyway, so the last part is, let me also show you the tunnel. So let me show crypto Ikev2 and SA, right? That looks good. So we have that tunnel 1 configured, and we will also have IPSEC, right? There you go. That's good, right? So we have everything, and you can also see my packets getting encrypted over here, right? So what we did now was we set up the VPN between R1 and R2, right? And we actually had a SVTI going from R2 to R1 and DVTI going from R1 to R2 to accommodate all my changes in the IP address over here, right? So if you have a dynamic IP environment over here, it would still work. Sweet. Okay, that's good. That's it for this video. Thanks, guys.